So welcome to this session. Just to confirm, my name is David Postlethwaite.
Yeah, I really messed up. Sorry.
I'm used to all sorts of different pronunciations. Yeah, at school you can have a field day with a name like mine, so there we go. Right, I'm a DBA for a large financial services company on the south coast of England. I've been a DBA for the last 10 years and I have to do SQL and Oracle for my sins. Previous to that, I was a developer using .NET, SQL Access, FoxPro and Oracle. And way back in time, I was a Windows and a NetWare administrator, if anyone is old enough to remember NetWare. I occasionally contribute to the blog on getanalyst.com, not very often at the moment, and my details are on the screen if you want to talk to me. Just to give you an idea of where I am, I live in a small little town called Swanage by the sea on the very south coast of England. If you ever look on England, you'll see that there is a small diamond-shaped island called the Isle of Wight on the bottom of the country. If you go to the western point, which is the Needles, and go due west, you will hit my house. So I live in Swanage. I work in this city called Bournemouth, and I cycle along the seafront. Or that's the view from my son's bedroom window at the weekend. We're having some nice weather at the moment. And that's a view from the little ferry that I have to cross to get across the entrance to Poole Harbour last winter as the sun rose on my cycle ride. And then I cycle along the beach to Bournemouth for those of you who are feeling jealous of me being by the sea. This is me. I speak regularly at SQL Saturdays all over Europe. In fact, that's when I last did my Shard Attack talk in Linz in Austria. And I'm also mad about steam trains, or trains in general. My town still has steam trains in it. And we had the most, well, what people call the most famous steam engine in the world, which was the Flying Scotsman visiting us at the weekend. And it's here for a few weeks, and that's it arriving with a load of people behind it. So yes, steam trains, we are still backward in my little town. Now, let's get going on sharding then. Traditionally, when our systems have started to slow down and we've needed more power, we've just gone out and bought more memory or bigger disks or extra CPU and added that to our current server. Worst case, we've gone out and bought a bigger and more powerful server to replace the current one. It's what you and I have done for the last 40 years. It's easy to do. Just plug it in, plug in the new bits and off you go. There's little to go wrong. Doesn't tend to cost too much for small changes, and it doesn't really take that much effort. I suspect everyone who's listening to this has done that sort of thing in the past on servers and desktops and laptops and the like. But buying a bigger and faster server can eventually become really quite expensive. And how big can you buy? There comes a point when simply buying a bigger or faster server becomes impractical or doesn't give the performance increase that you need. And running everything on one box, what we say, putting all your eggs in one basket, can become quite risky. And what if you've got customers all over the world? Do you want them all coming back to one server in one location? Would it be better for them to be able to write to a database near to where they are? So an alternative to just buying bigger is what is known as horizontal scaling, or scaling out. Here you buy several smaller servers, link them together, so even though your database is spread over several servers, it looks and acts like one database. Now this has been a common solution in the NoSQL world for quite a long time now. And buying several small servers is often cheaper than one massive server. And in theory, there is no limit to how big you can expand it. Having lots of servers gives you more resilience. And in theory, you can upgrade and apply patches much more easily. But more servers means more license costs, more electrical power, more infrastructure, and it's technically a lot more complex to set up and manage, as we'll see as we go on. In SQL, we can try and do this with replication, but anyone who has played with replication will know what a load of fun that can be. Now, Azure SQL Database has some pretty serious limitations. The maximum size for a standard database is 1 terabyte. I don't think that's been increased recently. I know there's been talk about it, which isn't very big in this day and age, rising to 4 terabytes for premium. But premium for either DTU or vCPU is very, very expensive. So if your transaction throughput is outgrowing your Azure database, or if you want to separate your data into different locations around the world, or if you need to isolate different customers into separate databases for compliance or performance or geopolitical reasons, but you still want to keep your data as one logical database for your own administration, then scaling out or horizontal scaling is an ideal way to try and achieve this. Now, splitting data across multiple databases is known as sharding, and it's Microsoft's implementation of sharding in Azure SQL Database, which we're going to have a look at today, or this evening, or this morning, or this afternoon, depending on which part of the world you're in. Now, before we delve too deep, let's have a look at some of the terminology used in sharding. Now, each database vendor uses slightly different wording for different terms, but these are the ones used by Microsoft. So first of all, sharding is defined as a technique to distribute large amounts of identically structured data, and that's the important phrase, across a number of independent databases. Now, the end users that use a shard are referred to as tenants, and they will be defined by a sharding key, and each tenant will have a unique sharding key, in this case an integer. Now, the databases that contain our tenants are called shards, and the shard key and hence each tenant will be linked to just one database or shard. Now, we'll also have a table called the shard map that keeps track of which shard key belongs to which shard. And in Azure, this is held in its own database called the Shard Map Manager. Now, all the shards that belong to a shard map is called a shard set. Now, tables that are sharded, in other words, the tables that have their data distributed across the shards based on their sharding key, are called sharded tables. Now, tables that aren't sharded, i.e. tables that need to exist on each shard but don't need to be split, are called reference tables. And all the data associated with a single value of a sharding key on a shard is called a shardlet. For sharding in Azure, to read and write to our shards, we need an application that is built using the Azure Elastic Database client library, which you can download from the Microsoft website. And this client library is available in .NET and also in Java. Finally, there are two features within Azure which can also be used with the sharded databases. These aren't part of the client library, but can be used, and they can also be used on Azure SQL databases as well as sharded databases. So first we have something called Elastic Database Query. And this is a bit like a linked server. As you've probably found out, the traditional link servers aren't available in Azure SQL Database. And an Elastic Database Query allows you to run queries against another SQL Azure database or data warehouse. Secondly, we have something called Elastic Database Jobs. This is a scheduler within Azure SQL Database that allows you to run native t-sql scripts against multiple databases in one go. So this is really handy for your scheduled admin tasks that you need to run on each shard. We're going to touch on one of these during the demo later on, but if you want to learn a bit more, I have a video on my YouTube channel on both of those, so you can get a bit more detail on them if you want to try them out, and I'll give you the link at the very end to my YouTube channel. Now, when we come to split our data into shards, we have two ways we can do this. The simplest approach is to create a separate database for each tenant, and this is known as single tenant sharding. It provides complete isolation for each tenant, allowing easy backup and restore. You can also scale each tenant or take the database offline without affecting anyone else. With a single tenant, each database is associated with only one sharding key, naturally. An alternative to single tenant is to place multiple tenants together on the same shard, and this is called, naturally, multi-tenant sharding. And this is suitable for an application that manages maybe large numbers of small tenants. In multi-tenant sharding, the rows in the sharded database tables must have that sharding key in them to distinguish between the different tenants. In a single tenant sharding, because there's only one tenant on each database, you don't necessarily have to have a sharding key, but it's recommended. And in both cases, with Azure sharding, the application tier, this application that we're going to write in C# later on, is responsible for routing the tenant's request to the appropriate database. Now, there are two models for multi-tenant sharding. Firstly, we have list mapping, and here we assign specific IDs, specific keys to a particular database, and this gives you the ability to control how many tenants go on each database, and you would most likely use this when tenants vary a lot in size to ensure that each shard has a similar level of workload. Secondly, we have something called range mapping, and here we assign a range of IDs to each database. So in this example, DB1 has got tenants 1 to 5, 2 has got tenants 6 to 15, and DB3 I can't see because of all the webinar stuff across the screen. And you would use this generally where each tenant is of a similar size. So you can say, right, we'll just stick 5 on each one and we'll get a similar performance on each database. Naturally, we can add more shards as our business grows, or we can scale up a particular shard to cope with growth of a particular tenant. So we can have vertical scaling within horizontal scaling. Now, once we've created our shards, we've got two ways of querying our database. Firstly, we have something called data-dependent routing. And here we can query just one tenant using the sharding key. So our client application, written using the Elastic Client Library, will pass the shard key of the tenant that it wants to read or write to the Shard Map Manager. The Shard Map Manager has a table within it called the Global Shard Map, and it will look up the appropriate database name in this shard map for the shard key that the client sent, and it will pass the database name back to the client database, to the client application, sorry. The client app can now query the correct database. Now, the shard database will have its own shard map as well, called the local shard map, and the shard will double check that you are querying the correct shard and that the shard is online for that shard key. If all is well, the database will run the query and return the data to the client. If not, you'll get some sort of error. Now, the client API will actually cache the shard details received from the Shard Map Manager within the desktop to avoid unwanted round trips on each request. And this is why the local shard map has to do a double check in case the shard has moved to a different database since the information was cached. Multi-shard querying, as the name suggests, queries multiple databases in one go, and this will most likely be used for your administration purposes. Here, the client application, again written using our Elastic Client Library, will query the shard map manager to find the names of all the shards in our sharding system, and it will then query each in turn. There we go. And return the results as a union all data set back to the client for it. Now, there's going to come a time when you're going to need to move a tenant from one shard to another. Perhaps a tenant in a multi-tenant tenant operation has become too big for its database and needs to be moved to a new shard, or maybe you need to consolidate some of the shards, move some smaller tenants together onto one shard so you can save some money. If you do move tenants, then obviously it's important that the shard map manager is updated with the change. You could move the data using t-sql and then update the shard map manager manually, but this will almost certainly lead to issues and lost data. A better way is to use the Azure Split Merge service. Now, this is an Azure web service that will manage the movement of the data, take the tenant offline while it's being moved, and update the shard maps for you. It requires another Azure SQL database called the Split Merge database, which will hold the status of each shard as tenants are being moved, so that the shard map manager knows that the tenant or the shard is or isn't available. Now, the link on the screen at the bottom gives basic instructions on how to build the example Split Merge service that comes from Microsoft. I have followed those instructions. They are quite involved, but not too difficult even for a DBA to manage. There are some bits which are out of date in it, which does cause a few issues. It uses the makecert command, which has been deprecated from Microsoft. Trying to translate the makecert command and parameters onto a PowerShell command beat me, but fortunately I managed to find a Windows 7 machine with makecert still on it, so I could still produce the certificate it needed. And once that is running, you can use code, PowerShell or CSharp to call that web service, or you can manually type the information into the web page that comes with the web service. Now, obviously, it's essential that you keep your shard map manager as accurate, well, completely accurate and up to date. Otherwise, data is going to end up on the wrong shard. If the global shard map on the shard map manager and the local shard maps on each shard get out of sync, then you're going to have problems. You won't be able to get the data into the shards. Keeping these two databases in line is essential to the safe running of your shards. Now, if you delete or rename a shard, either by accident or on purpose, you're going to end up with what they call an orphaned shard mapping. So the shard will either need to be removed from the global shard map, or the shard keys pointed to the correct shard. If you're going to use things like geo-replication and a failover occurs, you're going to need to have mechanisms in place to update your application to point to the new location of the shard map manager. You'll need to update the shard mapping details for all the shards in your shard maps as well. If you restore an Azure SQL database, it's going to be restored with a different name. And again, the shard map manager is going to need to know the location of the restored shard. And if either of the shard or the shard map manager database is restored to an earlier point in time, then they're not going to be in sync anymore, and you're going to have to try and resolve that as well. In this case, you're going to have tried and tested mechanisms in place to be able to recover your database quickly. Now, Microsoft have helped here by producing a C# class called the Recovery Manager, which is part of the Elastic Client Library. That's my wife's just started hoovering outside my door. Vacuum cleaning. There are other vacuum cleaners available. Right, so Microsoft have produced a C# class called the Recovery Manager, which is part of the Elastic Client Library. And this has a number of methods available to help resolve your mapping issues. I have given it a go. It did beat me in the end. I did sort of get it to work, but crushing your shards regularly does get a bit messy. But if you're going to use sharding, then you need to have a look at them and see whether you want to use them. But I have got it to detect the mapping differences and sort of resolve them. But the documentation has a lot to be desired, shall we put it that way. Now, we're not doing too badly for time. We're going to have a demo, and this is what we're going to attempt. I've got a table full of addresses from 21 different countries across Europe, which we want to split up. So in our demo, we will place records for different countries into different shards, and we will use the country ID as the sharding key. So in shard 1, we will place a range shard IDs 1 to 7, which is in our subset of data is going to include Austria and Denmark. Shard 2, we're going to use range 8 to 14, which includes Germany and the Netherlands. And Shard 3, we will have 15 to 21, which will include Poland and Slovenia. And that is going to be our shard set. We'll also have a reference table. And in this case, this is going to be our countries table, which we will join with the addresses table to get the country name. In my addresses table, I haven't actually got the country listed as shown on the screen, but it just helps for you to appreciate what's going on. Now, we could create a copy of this reference table on each shard, but we are going to use Azure external tables and Elastic Database queries to reference the table that exists in the European addresses database. We're going to use some t-sql and PowerShell to set up our shards, and then we're going to have a look at a C-sharp application that I've written that we can query this for the demo. So I hope you're ready. All the code and this PowerPoint is available. I will give you the link at the end of the screen, or you can go to the SQL Saturday Linz website, Linz in Austria, which has also got it on. Right then, let's see if we can get this to work. I hope you're all ready. I hope you're still listening. This is very disconcerting. Talking to no one. Right, let's just hide all that stuff. Right, come on. Now Management Studio is going to hang. That's a question for the end. How many other people find that Management Studio likes to hang just at the moment you want to use it? Here we go. Right, let's just minimize some of this. So I've done a bit of work beforehand. This is our European addresses database, which we want to split up just to see, so you can see what's in it. Let's just run a quick query. So it's just a series of rows. If we start from the top, I can explain the whole story. The data I've got has come from Kaggle. If any of you ever need any real-life data sets, Kaggle is a brilliant place to go. I've used it on some of my other talks on my previous talk on graph databases. It shows how great Roger Federer is a tennis player. That's my other passion in life, is tennis. This particular data set had 80 million rows, which was a bit too many for what I wanted, so I've just taken 100,000 per country we're looking at. So the data in the data set is just a longitude and latitude and an address and a city, though of course the ones I've chosen are all null, a postcode and the country ID that that country is from. And then we have a table with the countries in it. So just a series of European countries from Austria all the way down to Sweden. And there's about, as I said, about 100,000 rows in each country. There we go, except for some of the smaller countries which didn't produce quite so much data. So what we want to do is we're going to split this data and spread it across the first three shards, shard DB1, DB2 and DB3. Normally if you were doing this you would probably be using your European addresses table as one of your shards as well, but because I want to keep that intact for the next time I do this demo, which I'm doing at Data in Devon at the end of next month, I'm not going to wreck my European addresses database for this purpose. There's a number of things we're going to do to start off with. As I said, all this demo is available to you, so I've put down the 10 steps we're going to do. So we are going to split our countries into 3 different shards. So shard 1 is going to be 1 to 7, shard 2 is going to be 8 to 14, and shard 3 is going to be 15 to 21. I've created the databases already, so we have our Shard Manager database, which has got no tables in it. Shard DB1 has got no tables in it as well. Now we need 2 logins for this particular exercise. First login, which I called Shard Manager, is the login which will actually be creating and managing all the shard maps for us. And so this will require DB owner permissions on all of the shard databases. I've already created the login just to save a bit of time. And we also need another user which I've called Elastic User. And this user is the one that will actually be doing the read-write to the tenants. So it just needs read-write execute permissions on each of the shards. So let's get down and kick off. If I change over to the Shard Map Manager database, never trust the internet. Right, so hopefully I think we may have already created that one. Excellent. So that's the Shard Map Manager user created on the Shard DB, because it's going to be, when we install the sharding, it's going to be creating some new tables, some new store procedures and functions and the like. So the next one we want to go is to Shard DB1. Now I'm sure you know, never use the drop-down list once you have changed from master, because it effectively hangs Management Studio. Now we can create the Shard Manager user in our Shard DB1. Excellent. And now I'm going to create that Shard Elastic user. Now I'm going to give him read and write, and because there's a number of stored procedures that will be created when we build the shards, I've given him execute permissions as well. You could give him DB owner if you're not too worried about security and the like, but there we go. Now we have to build the actual the tables that we want on each shard. So I'm going to build the addresses table, and it's an exact copy of the addresses table on my European addresses database, because the shards won't do that for us. That's part of our build. Now the next thing I'm going to do, I demonstrate this just because not everyone is aware of external tables and the like. So we're going to create an external table here. So I'm still on Shard DB1. I've already done this bit, so we don't need to worry about that. We're going to create this external table so that we can then link directly to the one table on the European addresses. And for that we need to create an encryption key and then a scoped credential, which I'm just calling Elastic DB credential, with a login name and a password. So let's just run that in. And then we're going to create an external data source, Europe countries, of type RDBMS, connecting to my server called SharpPool Server, the database, European addresses, and it's using this credential called Elastic DB credential that we created up here. External tables, if you've not come across them, were introduced in SQL 2016. I believe they will eventually replace linked servers and the like in due course. There are limitations to what you can do at the moment, but I believe in SQL 2019 they're going to be adding more types to it at the moment. One thing to be very careful of when you create your data source is this extra little comma with no parameter after it. If you take that off, it does not work. Whether that's a bug or a feature or whatever, who knows. But do be wary of that. It's not a mistake. It does need to be there. Now we've created our data source, we could now create an external table and link it to that data source. So if I run that bit in, and now I can run, let's just refresh to show you that it's appeared. Microsoft Azure has gone down. We now have an external table called dbo.countries, but you won't get any properties. If you right click, there's not very much to see there. You can only script it out. Properties produces not very much at all. If Azure kept working for me. Yeah, there's nothing, you can't reconfigure it in any way. There's quite a few limited set of options. But what we can do now is run select star from countries, and that will actually pull back data from the countries table in European Addresses Database, which is rather nice. So that works rather well for us. So now we have set up Shard DB1. I've already done DB2, 3 and 4. You don't want to watch me going through all that stuff again. So our next stage is we now need to start populating our addresses table that we have created. So let me come over to PowerShell, and this is a Visual Studio Code, which now seems to be the way that we all do business in PowerShell. So I've got a simple query. In this case, we want to transfer or copy some rows from European addresses into Shard DB1. Now, as it says at the top here, we can't actually use the insert into command across Azure databases, which is why I'm using a PowerShell for this. So what I'm doing is I'm going to read from the European addresses table, just select all the rows for the range that I'm interested in. So here 1 to 7, I'm going to put that into a data reader, and then I am going to use the bulk insert command to insert those rows into my Shard database, in this case Shard DB1. Now if I was to do this from home, what will happen is that all the data in this database will be copied down the internet to a data reader in my laptop, and then when I run the bulk insert, it will play it all back over the internet back up to Azure. Obviously that's not a particularly efficient way of doing this, so what I'm going to do is I'm going to pick this up, and another feature that I like to show, which probably as you're all cloud experts already know, is if we come over to the Azure portal, we have PowerShell within Azure. If we give this a minute to start up, and if we run it here, it means that the data will be held within the Azure system, and we won't have to copy all the data down and back up again, which will make it a lot quicker for us. Okay, so if I paste that into here, off it'll go. Remember to hit return at the end. Now we'll leave that running because that's going to take a little while. Let's come back over here and let's start building our shards. So let's go to the top of this screen. Now to start using sharding, you need to download the Elastic client library. I put all the instructions at the top because, again, I found the documentation rather lacking in exactly how to do it. So you need to use things like NuGet to download it. Download this shard management PSM1 from this location, put them all in the right location, and then you can load up the shard management module. First thing we're going to do is we're going to create a new shard map manager object using our shard manager login and password to the shard pool server on and the shard manager database. So if we run that, If all goes to hand, we should come back. Maybe my son is back playing World of Warcraft and watching Netflix and watching YouTube at the same time. Right. So that's created a Shard Map Manager object. We can get a reference if we need to using that command. So the next thing we're going to do is we're actually going to create a shard map. Now, two ways you can create a shard map. We can use the list mapping or we can use the range mapping. In my case, I'm going to use the range mapping. That's there just in case you're interested in the syntax. So here I'm going to create a shard map. I'm going to use the new range map command. We're going to use an integer as the key type. We're going to call the range map range shard map, and we're going to join it to that shard map manager object that we just created. Excellent. Now we can create where have I gone? Now we can actually set up the individual shards. So we can add a shard using that shard map object to each shard in turn. So let's run close in. It shouldn't take too long. So this is actually creating the tables and some of the procedures that will go into the shard database. Excellent. And if we just have a look, we should get back that we now have 3 shards, DB2, DB3 and DB1. It doesn't bring them back in the right order. I can't explain why that is. So the next thing we need to do is we need to set up the shard mappings. Now we've created our shards, what are the mappings that are going to go across? This is the syntax for the list mapping, if you're interested in that, but again, we're using the range mapping. So just a reminder, shard DB1 is 1 to 7, DB2 is 8 to 14, DB3 is 15 to 21. But, and if you watch my video on this on YouTube, this is a mistake I made at the time when I was writing this and recording it. The range doesn't quite work as you expect. So when we add the range mapping, the range low is 1, but the range high is actually 8, even though we're going from 1 to 7. And this caught me out, which is why my split merge service would not work, because it couldn't cope with the fact that they were wrong. I don't know why this is. Similarly, for the next one, even though it's 8 to 14, we are doing 8 to 15, and similarly 15 to 22, which was a bit confusing for me. So let me run that. So if you do watch my one on YouTube, it does have the mistake that it uses the wrong set of numbers. And so the actual split merge part fails. Right, that was fairly quick. So let's have a look. If we run that, we should now get back. There we go. So status is online, shard location is that, value is 1 to 8. Again, shard DB2, 8 to 15, shard DB3, 15 to 22. Now if we go back to Management Studio, if we look at this shard, if I refresh this list, we've now got a whole series of tables with __ shard map management in their name. And similarly, if we go down to programmability and look at stored procedures, we've got another series of stored procedures, which is what the application is going to use. Now let's just flip back to Azure, and that's still going, which is not quite what I would expect. I was hoping that would be finished by now. Never mind, let us push on. Let's have a look and see what we have got. Let's just do a count and see how many rows we have. Yeah, so we've still got some zeros in there, which isn't quite what I was... Oh no, that's correct, isn't it? Because it's, sorry, me getting confused. Let's just run that again. So we have got so far 520,000 rows and no rows in the other two, which is what we're expecting on Shard DB1. So 1 to 7 is just populated. If I had time, we could run that on the others, and I've already pre-populated Shard DB2 and 3. So that is that finished. We'll leave this carry on running. It's obviously nearly there, or it's just not returned to say complete. So now we have now populated all the data into our shards. We have created all the store procedures and tables that sharding needs. Now we need a C-sharp application written using the client library to actually be able to talk to our Azure, to our shards. And I have created a C-sharp application. I've got two actually. This is the form-based one, which I think is a bit easier to understand, but I've also worked on one as a command line tool. I'm not going to take all the credit for writing this. I have used the Microsoft example and just slimmed it down and made it a bit easier to understand. What we're going to do when we build this, we've got some buttons here. This one will allow us to see the shard map, just like we saw in excuse me, in PowerShell. We'll also run a query to do a multi-shard query. The queries will text will appear in these boxes. We'll also have to do a direct query on one particular shard. This drop-down will be populated with the countries that we want to use, and we've also got one that we can do an insert against one particular shard. The results will appear in this window. As you can see, there is a little button where I was playing with recovery when I was crashing it, when I had the shard mapping slightly wrong, trying to get it to fix it, which is when I worked out you needed the strange numbering that we saw in the previous slide. For those of you who are into C#, this is what the code looks like. Again, I've put some instructions for me and for you if you want to try this yourself. So you need to download the Elastic Scale starter kit from this address. You can NuGet it down and install the Elastic Scale client and install all the bits and pieces you need. You can then add a reference to this client and you'll end up with two references to the Elastic Scale query, Elastic Scale shard management. Now a quick look at the code. There's a couple of points to point out. So we're going to create a shard map manager object here. Now when we connect to the shard map manager database, we used to use a standard connection string, as you can see here. So it's going to be to shard pool server, the shard manager database using the shard manager login. I've specified the range shard map name here. Now we also have a little stub of a connection string called the shard connection string, which has just got the login name and password of our Elastic user. And the reason why in this connection string we don't need to specify the server name and the database is because when we query the shard map manager for the name of the database and the server, it's going to return it. So the only bit we need to add is the login name and password. So you'll see that in a moment. Right, so I'm going to fill up that drop down with the countries. These are the texts for the queries that we're going to be using for our different things. So when we come to show the shard map, as I said, this is fairly simple code. I'm just going to use a string builder to hold the results. We're going to create a range shard map. We're then going to use try get range shard map to pull that out and get it back as this shard map object. We can then get all the shards. We can then use get mappings grouped by shard, etc. Once we have all the shards, we can then loop through all the shards in our shard map and return the results to the screen. Just doing, as I said, a string builder and sticking them on the screen. So that's just doing what we've already done in PowerShell. Now when we come to doing our multi-shard query, again we get our shard map, we get our shards, and we do a multi-shard connection. this time, which is a special function available in the library. Once we have our multi-shard connection, we can do our query. We're going to include the shard name in our output. We have a special option here called partial results. So if one of the shards doesn't return quickly enough, we can just ignore it and carry on. And then with a little bit of formatting, I'm going to read all that into a data reader, just loop round and print the results out to the screen. For the select, again, we're getting the shard map out. We're getting a connection string. This time we're going to use open connection for one key, and we're passing in our sharding key of the country ID. We can then run our query again into a data reader, and I'm just looping round. I think I'm just pumping out the first 10 rows, a little bit of formatting, which works for most countries unless they've got a long name. And you can also get the server name, the database name, and the connection string out as well from that connection, which can be quite handy when you're trying to debug and stuff. So there's more code in here. As I said, you can download this and take a look, but as it's 10.2, let's start up and see whether it will work. Now the first thing that's probably going to happen is my antivirus is going to kick in and go, you're creating a dodgy executable. Are you really sure you want to do this? But we'll see if it's in a happy mood today. Excellent. Hopefully you can all see this. So if I click on the show shard map, it will now return those shard keys. Notice that the order doesn't return them in any particular order. It's just pulling them straight out of the table. It doesn't seem to have any order to them. For a multi-shard query, I'm just going to do a count star and then return the data from the addresses table joining to that countries table, which is that linked table back to the European addresses table, and it will run that. Doesn't all fit on the screen. I've actually got an order by on this one. So if I run that one, it will now run and hopefully return some data. He said, there we go. So in this case, it's returned the counts so we can see how many different, and again, you can see even with the order by, it's not actually returned it as we expected because the way it's returning it doesn't quite work as we wanted it to. So there is a bit of work you'd have to do if you wanted to actually get them in the correct order. Now, if you want to select the data, I'm going to select the top 10 rows from a particular country. Which country shall I select today? Let's go for Denmark. And if I select data, that will now pick that up as we saw, work out the shard table it needs to talk to, and here are the first 10 rows, and as I said, it will tell us the shard name, server name it was using, the database name, and you can see the connection string that it's actually used to do that connection. So we can see it's going to the shard pool server, shard DB1, it's using the Elastic user, and it's given it this huge long application name. And there's a connect retry count as well, which we haven't specified. Finally, if we wanted to insert some data into our Denmark one this time, I've just got an insert command. And again, I've just specified the values to insert. And if we run that, that should then insert some rows, and again, or one row. And again, it's telling you all that information. Now, if I pick up this bit and add it there, hopefully we should see that it has added that row of data to the yeah, so there we go. So it's added that one row of data to my Denmark table. So this is a very, very brief and quick look at what you can do in sharding and the like. Finally, what we can do if we want to split and do the split merge, I'm not actually going to run it because we're nearly out of time and I need to do my demo. If you create the split merge tool, you end up with a cloud service classic, which will be sitting here. As I said, the instructions do work most of the time. I did have to do this about 3 times when I was setting it up yesterday. But there is our split merge running. There is the URL to the website. Rather annoyingly, it gives it as HTTP, but you actually need to put HTTPS in it. And here is what it looks like. And you can then, if you want to use the website, fill in all the information necessary to move. So you can put the shard map manager name in, the database, the username and the password, what the shard map is, what your split is going to be, whether you want to move the split, the target you want to send it to, and the like. Similarly, we can do it via PowerShell as well. I have the split merge over here. Again, that's included. You have to load up all the modules, create a shard map manager range. Interestingly, we have to create a schema, which is something we haven't had to do because obviously the shard map or the split tool needs to know which table in your shard you actually need to split, because up to now we haven't specified it. So we have to specify a schema. It only gets mentioned when you start doing a split merge function. It's not mentioned anywhere else in the documentation, but you would have thought that's the sort of thing that you would need anyway. So you can actually define, because you may have reference tables in your database which you don't want to split, so you have to specify what you want to split. You then specify all the necessary parameters, and again, off it will go. You need to have a certificate and the like installed, and it will run. As we're nearly time up, I'm not going to try doing that because it does take a little while to run, but it will work. So if we come back to the PowerPoint, no, that's not PowerPoint, is it? Let me just wind up with a few thoughts. We've looked at how it works. What are the problems inherent with sharding in Azure? Well, first of all, your data is spread over several databases, so that we're going to have a few issues. You've got to have some pretty complex code, as you've seen, to ensure that you talk to the correct shard. We've gone beyond just simple t-sql and the like to using .NET, C# or Java code. If you get this wrong, you could end up with data in the wrong place, seen by the wrong people. And if you're in Europe, GDPR is going to kick in and you're going to end up with a massive, great big fine. And of course, the data is spread across lots of tables and lots of databases. There's nothing to stop people just writing straight to the shard, because it is still just a database. It's just a standalone database. And again, you could end up with data in the wrong shard. You could improve security by using something like row-level security to control who can get to which rows in which tables. That was introduced in SQL Server 2016. Again, I have a video on my YouTube channel on row-level security and other security features. Since the data is now in different databases, if you want to run multiple queries or multi-shard queries, you can't guarantee the transactions completing across all the shards, because it just fires them off and hopes that they work. You're going to have to find other ways to ensure that that they've all completed. You can't do multiple joins across shards due to performance constraints, so they say, because of the way data has to be compiled. Data integrity constraints aren't going to work across shards either, because they are separate databases. You're going to have your application to look after it. All those round trips to the shard manager server is going to slow things down. You're going to have to test that. We've already talked about recovery and the like, how you're going to cope with geo-replication, failover and the like, corrupt shard mappings and things like that. The real big difference between sharding in SQL Server as opposed to NoSQL sharding, in NoSQL sharding is part of the database. It's all controlled and built into the database. It is more robust. In SQL Server or in Azure, it's basically just a set of standalone databases which you are turning into a shard just by using external code. Another thing I would say, the code that I've downloaded or the examples, they haven't changed for 2 years, I think. It's like Microsoft have thought this is a great idea, worked on something, and then they're not working on it anymore. So I can't tell you whether this is going to be moved forward in the next few years or whether it's just an idea that has been put forward, someone's done a bit of work and it's just been left. So whether it's a safe thing to use, whether there's going to be any support long term, I am aware of when I did this talk at my Southampton user group, a consultant was there and he'd actually used this a couple of years ago on quite a big project, so it has been used, but whether Microsoft are going to support it long term, I can't really say. So I hope that has given you an introduction to horizontal partitioning. The links, if you want to get hold of all the code and all the examples, are on the screen. My YouTube channel, again, is on the screen there as well. If you want to watch this video again, it's on there without all the delays while things happen. There we go. That is it. And we've reached 6 o'clock. Jason, are you still there?
Yes, I'm still here. Sorry about that. I was muted. Totally forgot about that. Yeah, so thank you for presenting here today. And with that, we do have one question.
Okay.
And actually, the person that had the question did leave, but I think we'll ask it anyways. They were seeing a lot of parallels between partitioning structures and strategies. Are they truly similarities, or is it dangerous to draw conclusions where they don't exist?
I think it would be dangerous to draw conclusions. As I was just saying, lots of people have talked about sharding earlier this year or this time last year. I thought it'd be interesting to have a look and see what it is. And as I said, the code, it's not part of the database, which replication is. This is literally C# or Java code. I have actually run it on a local SQL server. It will quite happily create your databases. You don't have to have Azure. The only bit that seems to require Azure is the split merge service. I think it's a completely different thing, and as I said, it's a C# application which is controlling it. It's not a database. It's just a way of linking databases together.
All right. Well, thanks again. There aren't any other questions out there. So with that, I'm going to wrap things up today. And thank you, everyone, for attending. Thank you, David, for presenting.
That's all right.
Looking forward to having everyone back in on the next session, which I believe is next week on Thursday. Thank you.